Hello, Professor Smiley. Today we'll be performing a chi-squared goodness of fit test on this six-sided die to determine if we have enough evidence to say that it's fair or it's not fair. This is a six-sided die. It's a little different than normal ones. It's completely statistics-based, which I thought was interesting. So we have positive outlook, data error, retry, insufficient data. It is certain, outlook negative, and cannot be certain. It's normally for like fortune telling or whatever, but I think it's a very fitting die for this class. So we'll be performing 100 of these rolls, and then we'll record all of our data on this little notebook I have here, and then we'll go in over what the data means and how we can interpret it for our hypotheses. Our null hypothesis will be that the dice is fair, which is just the generally believed notion. And our alternate hypothesis will be that the dice is not fair, or that there's sufficient evidence to say that it's not fair. But let's go with these 100 rolls. Roll number 1, error retry. 2, error retry. 3, insufficient data. 4, insufficient data. 5, insufficient data. 6, data error retry. 7, outlook negative. 8, outlook negative. 9, insufficient data. 10, outlook positive. 11, we're back for number 11. Number 11, cannot be certain. Number 12, insufficient data. Number 13, cannot be certain. Number 14, outlook negative. Number 15, it is certain. Number 16, outlook negative. All right. Number 17, cannot be certain. Number 18, it is certain. Number 19, cannot be certain. Number 20, outlook positive. Number 21, data error retry. Number 22, data error retry. Number 23, data error retry. Number 24, outlook negative. Number 25, cannot be certain. Number 26, data error retry. Number 27, it is certain. Number 28, data error retry. Number 29, data error retry. Number 30, it is certain. Number 31, it is certain. Number 32, cannot be certain. Number 33, insufficient data. Number 34, insufficient data. 35, 35, we got cannot be certain. 36, outlook negative. 37, insufficient data. 38, outlook negative. 39, data error retry. 40, cannot be certain. 41, outlook negative. 42, cannot be certain. 43, it is certain. 44, outlook negative. 45, data error retry. 46, outlook positive. 47, cannot be certain. 48, cannot be certain. 49, it is certain. 50, insufficient data. 51, it is certain. 52, outlook positive. 53, data error retry. 54, positive outlook. 55, insufficient data. 'It is certain' for number 56. 57, outlook negative. 58, it is certain. 59, insufficient data. 60, data error retry. 61, it is certain. 62, outlook positive. 63, outlook negative. 64, data error retry. 65, outlook positive. 66, outlook positive. 67, data error retry. 68, outlook positive. 69, outlook negative. 70, cannot be certain. 71, it is certain. 72, data error retry. 73, data error retry. 74, outlook negative. 75, cannot be certain. 76, cannot be certain. 77, cannot be certain. 78, data error retry. 79, insufficient data. 80, cannot be certain. 81, outlook positive. 82, Outlook negative. 83. Insufficient data. 84. Outlook negative. 85. Cannot be certain. 86. Insufficient data. 87. Outlook positive. 88. Outlook negative. 89. Outlook negative. 90. Outlook negative. 91. Outlook negative. 92. Cannot be certain. 93. Insufficient data. 94. Cannot be certain. 95. Cannot be certain. 96. It is certain. Certain. 97. We're getting Outlook positive. 98. Outlook negative. 99. Outlook negative. And lastly, number 100. Outlook positive. And with that, we've completed 100. Now we will discuss how to perform the chi-squared goodness of fit test on our 6-sided dice experiment and everything I did to reach my conclusion. First off, our null hypothesis, which is that the dice is likely fair, and our alternate hypothesis, which is that the dice is likely not fair. Before we begin this test, we have to first go through some criteria to make sure that our experiment is valid in a chi-squared goodness of fit test. So we know that we have random sampling. Our expected values are greater than 5, and in order for them to be greater than 5, we need a sample size of about 30 minimum, but we have 100, which is great. It has to be categorical, so each value has to fit into a category. Here we've done 1 through 6, with our 1 through 6 being number 1, Outlook positive, number 2, Outlook negative, number 3, data error retry, number 4, insufficient data, number 5, it is certain, and number 6, cannot be certain. Next, everything in this is independent, and one outcome on the die does not affect the other outcomes. So we can perform the chi-squared goodness of fit test. Upon performing the test with our formula for it, which is the observed amount minus the expected amount, square that value and divide it by the expected amount for each category, we will get our chi-squared value after summing all of those. So after doing all of that, I end up with a value of 3.68 as our chi-squared test statistic. Our expected value, keep in mind, is 100 over 6, which comes out to 16.67. Our degrees of freedom is going to be 6 sides of the die, minus 1 and minus 1, which comes out to 5 at a significance level of alpha of 0.05, which when looked at on a chi-squared test sheet, we get a value of 11.070 as our critical value. Now we know that our chi-squared test statistic is 3.68, and our critical value is 11.07, meaning that because our test statistic is lower than our critical value, we are able to fail to reject the null hypothesis, meaning that the dice
likely appears to be fair.